a question, a moles problem, if you like, using mole ratios, but also using a formula, a mathematical formula with moles equals mass of a molar mass, which I've written underneath that table. Okay, so let's have a look at the question. It says, what mass of hydrogen and oxygen makes 4.00 grams of water? Okay, so what we're looking at is what mass of H2 and what mass of O2 makes 4 grams of H2O. Okay, so the equation for the reaction is in the very top of the box, and you can see H2 plus O2 makes H2O. Okay, now if you lay out your calculations like this, in this kind of table form, it makes it a bit easier to follow. So we have the amount in moles in the yellow, in like the yellow row. We've got the mass in grams, which we're going to be looking at, and then the molar mass, which is the mass of 1 mole. Okay, so that's the mass of 1 mole. And we get that from the atomic masses on the periodic table. So the first thing I'm going to do is I'm going to write the 4.00 grams into the space underneath water. Okay, because that's the information I've been given in the question. And what we're going to find out is the mass of H2 and O2. Now let's write the molar masses of those things. So the molar mass of H2, okay, so H2 is made up of 2 lots of 1.01, okay, and you find that mass, this 1.01 is the atomic mass of each hydrogen atom, and that's found on the periodic table. Okay, so the molar mass of H2 is 2.02 grams per mole. Okay, for O2, we've got 16.00 for each oxygen, and there are 2 of them. So we end up with a molar mass of 32.00 grams for O2. And for water, what we've got is 2 times 1.01, so 2 times that atomic mass of hydrogen, plus 16 for oxygen. So we end up with 18.02 grams per mole. Okay, so I'm just going to remove those so we've got a clearer place to carry on. Okay, so I've written the molar masses, I've written the mass, okay? The next thing we also need to do is to balance the equations. Now I'm doing that now because I didn't want to get you confused with the mole ratios in front, the balancing with the molar masses. So let's balance this equation. So if we balance it, what we'll find is we'll have two H2s reacting with 1 O2 to make 2 H2Os. So those are the numbers we put in front to balance it. Those are also the mole ratios, okay? So whatever ratios we write in that yellow box have to be in the same kind of ratio as well. So we've got 2 bits of information here, 4 grams and 18.02, which is the molar mass. And using this equation over here, mass divided by molar mass, we can actually turn that into moles and put it in that space there. Okay, so let's go ahead and do that now as a calculation. So we're going to work out the moles of H2O. Okay, so that's mass over molar mass. So the mass is 4.00, the molar mass is 18.02. And when we work that out, let's try this over here. So we'll do we don't have to put the 0 in, but let's do it. 4.00 divided by 18.02. When we calculate that, we get 0.22, and I'll round that 1 up to a 2 because the 9's following it. So I'm just going to do it to 3 decimal places. The reason I'm doing that is because sometimes when you round up to 2 decimal places or 1, you lose a bit of accuracy. Okay, so that means I've got that many moles of H2O. So I'm going to write that in the box up here. Okay, now then, using the mole ratios, we can work out the moles of everything else. The easiest way to do it is by just looking at what happens when you go from one ratio to the next. Okay, so if I show you this in a different color, it might be a little bit easier to kind of focus on. So if I go from 2 to 1, okay, 2 moles to 1 mole, that means I am dividing that by 2. Okay, and if I go from 2 to 2, I'm not doing anything, it's the same number of moles, okay? So to go from 2 to 1, I'm dividing by 2, which means I also must have to do the same to this number of moles here. So if I divide 0.222 by 2, I end up with 0.111 moles, okay? Now, since the mole ratios for water is in the same mole ratio for H2, okay, I can just write 0.222 moles in that space, okay? So at the moment, I've now written the moles of everything, right, from that 4 grams, okay? So the question's actually asking for the mass of hydrogen and oxygen, right? So the actual mass of hydrogen and oxygen, and we have the moles of hydrogen and oxygen. So what we need to do is we need to turn those moles into masses. The way we do it is we rearrange our equation so that we're looking for mass. Okay, so we start with mass equals moles times the molar mass. Okay, so when we do that, we put in, so let's do the mass for O2 first. Okay, so we're going to ignore the numbers in front of O2 and H2 because we've already used the mole ratio over here. We already used those numbers in front, so we're not going to use them again, right? We're just going to go straight with whatever we have. Okay, so moles for O2 is 0.111, and we're going to multiply it by its molar mass, which is 32.00, right? So that's for oxygen. So let's put that into our calculator. Okay, so we've got 0.111 multiplied by 32 grams. I won't bother putting 0.00, and we end up with an answer of 3.552. I'm just going to keep it as that, just because of accuracy, right? So our answer is 3.552 grams, okay? So that's the mass of oxygen that we would need. So what about if we wanted to work out the mass of H2 that we need? So we use the same formula, mass of H2, mole equals moles times molar mass, but this time we use the moles for H2, right, which is 0.222, and we use the molar mass for H2, right, which is over here, so that's 2.02, and when we calculate that through, let's have a look at what that will be. So we're using the molar mass of H2, and we're using the moles of H2, so we've basically used these two values here, right, in our formula. Okay, so let's work out what the final answer is then. So let's have a look. So we're going to do 0.222, and we're going to multiply that by 2.02. Okay, and we end up with let's try that again, 0.448. So 0.448 grams. Okay, so let me just remove some of this extra colour. Okay, so it means that 0.448 grams and plus 3.552 grams will make 4 grams, should make 4 grams of H2O. Okay, now we can check whether we're right because using the law of conservation of masses, both of the mass of the H2 and the mass of the O2 should both add up to 4 grams. So let's just check whether that does or not. So let me add, I mean, I'll keep it in the calculator like that, but if I add 3.552, I should get roughly 4 grams, which makes sense.